Here we go, example 8.6. We've got a boy pulling a sled of some sort, and let's say here's the ground right here, and here's our sled. I'm just gonna make it a box. We do have a lot of boxes here, don't we? Yeah. I just don't have anything right now to try to draw some sled. And anyway, this sled is moving across the ground, and so it's displacing its position. And he is applying a force to it at 29 degrees above the horizontal. All right. Okay, so that's our force. 29 degrees right there. You could also say 29 degrees below the horizontal, I guess, but anyway, our force from the boy should be 11 newtons. Okay, what's the mass of our sled? M sled equals 6.40. In fact, I'll write that in black so it stands out. 6.40 kilograms. Man, that's really squeezed in there. But you get the main idea. And we want to find what is the work done by the boy. Okay. So boy equals, we don't know, and we want to find the final speed of the sled after it moves a certain displacement. And by the way, what is our displacement? D equals 2.00 meters. And we are told one other thing about the velocities, right? We want to find the final velocity, but the initial velocity has some motion, or it has some value other than 0. It's 0.5 meters per second, and v final is, we don't know. We want to find that out. So that's the other part we want to solve. V final equals, not sure. Okay, one more thing we need to add to this sled that might help. What other force can we add to it? Well, we know that it has mass, but that mass in conjunction with gravity creates a force that we call weight. So mg would be our mass, 6.4 kilograms times 9.8, so that gives us 62.8 newtons. 62.8 newtons. Okay, so let's go about trying to find the work done by the boy. In fact, you know what? I'm going to switch to black just because, well, just because. Work done by the boy. That should be the force done by the boy, 11 newtons, times our displacement, d, which is 2.00 meters, times the angle that force is from the direction of motion. Well, again, if this right here is our direction of motion, or our direction of displacement, you might say, then what angle is that from that direction of displacement? That should be 29 degrees times a cosine of 20, not 92, I'm dyslexic this morning, or this evening, 29 degrees. Okay? That's 11 newtons times 2 meters times cosine 29. That gives us 19.2 joules of work that the boy does. And that's it. By the way, one thing that really helps and makes this simpler is that we're not dealing with friction. Okay, so we're not dealing with a work done by friction against the boy's sled. It's simply the boy doing work. And if you think about it, think about how much easier your life would be if, well, of course, without friction, friction keeps our cars on the road too. But if there wasn't friction, you could do work a lot easier, a lot more efficiently. But friction is always acting against us, for better or for worse. So that's the work done by the boy. But it's also true that the work done by the boy is really the net work done on the sled, because after all, there is no friction. And that equals, if we refer to our work kinetic energy theorem, 1/2 mv final squared minus 1/2 mv initial squared. And that's where we're going to be able to solve for what the final speed is. It's starting at this speed right here. We don't know the final speed, but we can use this to determine that. So what I'm going to do is I'm going to simply, I'm going to solve for V final. I'm going to rearrange all this to solve for V final, and then I'll just plug everything in. So let's see here. I want to, well, we're just going to write this in terms of net force. I'm going to factor out this 1/2 m first, or you might say m over 2. So net, and you might do this a different way mathematically too, but from this point on, it's really just algebra. M over 2 times Vf squared minus Vi squared, close parentheses. And so let's just bring our m over 2 across to the other side. So that would be 2 times net work over m equals W. Oh, not W. That should be V, right? Vf squared minus Vi squared. And so Vf squared should be 2 times net work divided by m plus Vi squared. Which means that to solve simply for V final, it's the square root of all that stuff. 2 times net work over m plus initial velocity squared. Simply nothing more than plug and chug now, so let's put it all in. That should be equal to 2 times, what's our net work? We just found that up here, right? That's 19.2, that's a point right there, 2 joules divided by, what's the mass of this thing? 6.40 kilograms. 6.4 kilograms plus Vi squared. What's our initial velocity? Our initial velocity is, we just have it here, 0.5 meters per second. 0.500 meters per second. That quantity squared, right? So there we go. Put it all in. Whatever order you do it in is fine. Just make sure you do it right and you watch your parentheses and your square roots. But we should have that our final velocity should be a value of 2.55 meters per second. There we go. We've got our work done by the boy, and we've related that to velocity through the work kinetic energy theorem. So there you have it. We've done everything up to example 8.6, and we're going to move on to actual energy after this. But hopefully that all makes sense to you. Please see me either in class or actually after class if you have any questions, and I'll be glad to help you. And I'll see you then.